Let's look at some example problems in 3 where we want to determine whether the given distributions are binomial distributions, and we want to find the probability of events using binomial distributions. All right, so what is a binomial probability experiment where we get an actual binomial distribution? You have a fixed number of trials. Trials are independent. Each trial must only have 2 outcomes. That's your binomial part, okay, meaning true, false, yes, no, and so on. And the probability of success is the same for all trials. So surveying 100 college students and recording if they like pirates or ninjas better. Is this a binomial probability experiment? Well, yes, because there's only 2 outcomes here, and you have a 50-50 chance of picking which one, so this is definitely. 5 cards are selected from a standard 52 card deck without replacement. That's a key right there. The number of 3 selected. This is not, there is a fixed number of trials, but because you're not replacing the card, notice that these are not independent. The probability of drawing the first 3 is going to be different than the probability of drawing the second one because there's already a card missing. So this is definitely not a binomial. All right, multiple choice questions each have 5 possible answers, A, B, C, D, or E, one of which is correct. Assume that you guess, which you guys do often, right, the answers to 3 such questions. Use the multiplication rule to find the probability you get wrong, wrong, and correct, where C denotes a correct answer and W denotes a wrong answer. Okay, so notice there are 5 choices, A, B, C, D, E. So you have a 1 in 5 chance, pretty good, not really good though, of getting the right answer, and 4 in 5 chances of getting the wrong answer. So what this means in probability, you get a 1 out of 5 chance of getting it correct, 4 out of 5 chance. Remember, the word and in probability means to multiply. Now they told you to multiply, but if they didn't tell you that, whenever you see and, so this is the probability I get the first question wrong and the second question wrong and the third question correct. So all I do is I take these probabilities and I multiply them using my calculator, and I get a decimal answer. All right, beginning with the wrong, wrong, correct, make a complete list of the different possible arrangements of 1 correct answer and 2 wrong answers, and then find the probability for each entry in the. Well, we already know the wrong, wrong, correct, but then also you could get the first one wrong, the second one correct, and the last one wrong, or you could get the first one correct and the second and the third ones wrong. Same thing with the probabilities. We already knew this one. Notice here I'm still going to multiply wrong, correct, wrong. Multiplication, remember, order does not matter, so you should get the same probabilities for all 3 of these. Based on the preceding results, what is the probability of getting exactly 1 correct answer when 3 guesses are made? In other words, this means if you get 1 correct, you either get the last one correct, or the second one correct, or the first one. Remember, the word or in probabilities means to add. So the last one correct, or the second one correct, or the first one correct. Add up the probabilities to get your answer.